reduce the radicals, and hopefully this will give us some like radicals to work with. For example, in this problem, none of the radicals are alike. However, we can simplify the radicals by finding the prime factorizations and dividing the exponents by the index. We will assume you know how to find a prime factorization. The prime factorization of 50 is 2 times 5 squared with an x, plus 5 times the square root of 27, which is 3 cubed, minus 3 times the square root of 2x, 2 is already prime, minus 2 times the square root of 108, finding its prime factorization is 2 squared times 3 cubed. We can now simplify by dividing the exponents by the index of 2. 5 squared can come out as a 5, giving us 20 times the square root of 2x. 3 cubed has 1 3 coming out, and we have a remainder of 1, so 1 3 will remain in the radical. Multiplying, we now have 15 times the square root of 3. Minus 2 times the square root of 2x, minus, we can pull 1 2 out, dividing the exponent by the index, and we can also pull 1 3 out. There's a remainder of 1, so 1 3 remains behind. We now have 12 times the square root of 3. We're now ready to combine like radicals. Square root of 2x makes like radicals, and 20 minus 2 means we have 18 of these square roots of 2x. We also have like radicals on the root 3, and 15 minus 12 is positive 3 of these square roots of 3. This is our final solution. Let's try another example where we have to simplify the radicals first before we can find any like radicals. In this problem, we have cube roots, but the process is identical. We must find the prime factorizations of the numbers to see if we can do any simplifying. 81 is 3 to the 4th power, x cubed y, minus 3y times the cube root of 32. Its prime factorization is 2 to the 5th, x squared, plus x times the cube root of 24y. 24's prime factorization is 2 cubed times 3, y, minus the cube root of 500. Finding its prime factorization by dividing out all the prime factors gives us 2 squared times 5 cubed, with x squared, y cubed. We can now go back and simplify by dividing all the exponents by the index and leaving any remainders behind in the radical. 3 to the 4th, dividing the exponent by 3 gives us 1, and 1 3 remains in the radical. X cubed, dividing the exponent by 3 means 1x can come out. We now have 3x times the cube root of 3y, minus 2 to the 5th. When we divide that exponent by 3, we get 1, but there's also a remainder of 2. 2 times 3 on the outside gives us 6y times the cube root of 2 squared, or 4x squared, plus 2 cubed, dividing the exponent by 3 gives us 2 to the 1st, giving us 2x times the cube root of 3y, minus, 5 cubed pulls a 5 out, y cubed pulls a y out. We have 5y times the cube root of 2 squared, or 4x squared. Notice we have like terms, x cube root of 3y. 5x cube root of 3y, adding the 3 and the 2 together, and also negative 6 and negative 5 gives us negative 11 of these y cube root of 4x squareds. This is our final answer.